Welcome to the TS Learning software. My students and I are thrilled to have you join us in this educational journey.
Hello, I am KP. This section is about fundamentals of set theory. What is the set? A set is a collection of distinct and well-defined objects. Each object in the set is called an element or member. A set usually shows its elements inside curly brackets. And is named with a capital letter. And to separate and distinguish the elements inside it, we use commas. Membership is indicated by the symbol, member sign. And we read apple is an element of B. If an element does not belong to a set, we use and we read cherry is not an element of B. Representation of sets. Sets can be represented in two main ways. 1. Roster or listing form. The elements are listed inside curly brackets. 2. Set builder form. The elements are described by a property or rule. Key definitions. 1. Empty of set or null set. A set with no elements. It is denoted by the symbol. 2. Finite set. A set with a limited or countable number of elements. The number of elements in this set is 6, so it is a finite set. 3. Infinite set. A set with infinitely many elements. The dots mean and so on, continuing indefinitely. 4. Subset. The set B is a subset of C if every element of B is also in C. It is denoted by the symbol, subset sign. So B is a subset of C. All elements of D are in set C, so D is a subset of C. Since at least one element of E does not belong to C, E is not a subset of C. 5. Proper subset. A set B is a proper subset of C if, but B is not equal to C. It is denoted by the symbol, proper subset sign. B is a subset of C, but B and C are not equal, so B is a proper subset of C. Note: if a set B is a proper subset of C, then B is also a subset of C. But the opposite is not always true. 6. Universal set. The universal set is the set that contains all the elements under consideration in a particular discussion or context. It is denoted by the symbol U, and it depends on what we are talking about. For example, if discussion is about students in a class, then U is the set of all students in that class. And if the discussion is about positive two-digit even numbers, then the universal set is equal. The dots mean that the elements of the set continue consecutively following the same pattern. Set operations and relationships. Now we want to describe how sets combine, overlap, or exclude each other. 1. Complement in sets. Complement of a set A is the set of all elements in the universal set U that are not in A. It is denoted by the symbol A prime or A complement. For example, if the universal set is and the set A is, then the B complement is. The set that you see belongs to universal, but not to A. 2. Union of two sets. The union of two sets means putting all the elements from both sets together, without repeating any element. If we have two sets A and B, the union is written as. This is read as A union B. It means all the elements that are in A or in B or in both. Example: find the union of the given sets A and B. Solution: first, we will write all the elements from both sets. Now we will remove the duplicate elements. Therefore, the final result is. Example: let the universal set be. Find the union of A complement and B. Solution: first, we will find the complement of A in U. Now we will find the union of a complement and B. We removed the duplicate elements. Three. Intersection of two sets. The intersection of two sets means the elements that are common to both sets. If we have two sets A and B, the intersection is written as. This is read as A intersection B. It means all the elements that are in both A and B. Example: find the intersection of the given sets A and B. Solution: we just need to find the common elements of the two sets. Note: if there is no element that belongs to both A and B, then A and B are disjoint sets or. 4. Difference of two sets. The difference of two sets contains elements in the first set that are not in the second set. If we have two sets A and B, the difference is written as. This is read as A minus B. It means all the elements that belong to A, but not to B. Example: find the A minus B. Solution: first we find the elements of the second set inside the first set. Clearly, only the common elements are identified. Now remove the common elements from the first set. Finally, we list the elements that remain in the first set. Note: A minus B is equal to A minus the intersection of A and B. Mathematical and logical symbols. We use various mathematical and logical symbols to represent concepts clearly and to simplify expressions. And or for all. There exists set operations and relationships in symbolic form. Complement. For all x that are member of the complement of A. It means x belongs to the universal set, and x does not belong to A. X does not belong to A. Complement of a set A is the set of all elements in the universal set U that are not in A. Union. For all x that belong to the union of A and B, it means x belongs to A, or x belongs to B. X belongs to A. X belongs to B. The union of two sets A and B means all the elements that are in A or in B or in both without repeating any element. Intersection. For all x that belong to the intersection of A and B. It means x belongs to A, and x belongs to B. X belongs to A. X belongs to B. The intersection of two sets A and B means the elements that are in both A and B. Difference of two sets. For all x that belong to A minus B. It means x belongs to A, and x does not belong to set B. X belongs to A. X does not belong to set B. The difference of two sets contains elements in the first set, A, that are not in the second set, B. Note: the set A minus B can be obtained by this formula. If a set has at least one element, then it is not a null set. If there exists an x in A, then A is not the empty set. Your effort is appreciated.
Thanks for watching.